In this video, we will explore income elasticity of demand and cross-price elasticity of demand. Suppose you are interested in studying the effects of income on healthy and unhealthy habits. A powerful tool that could help you in your research is income elasticity of demand. Income elasticity of demand is equal to the percent change in demand over the percent change in income. It measures how responsive are consumers to a change in income. When working with demand equations, it can be helpful to write the income elasticity coefficient in terms of a slope coefficient, as we have here in the last line. The sign of the coefficient determines whether the good is an inferior good or a normal good. Recall that for an inferior good, when income increases, demand decreases. This suggests that there is an inverse relationship between income and demand, so the income elasticity of demand coefficient will be negative. For normal goods, there is a positive relationship between income and demand, both moving in the same direction, so the income elasticity of demand coefficient will be positive. When the income elasticity of demand is greater than 1, we call the good a luxury good. This suggests that in relative terms, that when the income goes up, demand goes up by even more, or when income goes down, demand goes down by even more. For instance, a good would be a luxury good if a 5% increase in income led to a 10% increase in demand. To establish that an increase in income led to better smoking habits, what sign would the income elasticity of demand for cigarettes have? Please take a second and answer this question. For this to be true, cigarettes must be an inferior good, so you would have to calculate a negative income elasticity of demand coefficient for cigarettes. Estimates of income elasticity of demand for beef in developed nations like the United States are positive but less than 1. In developing nations, the estimates are greater than 1. Suppose that in the United States, the income elasticity of demand for beef is 0.3 and income increased on average 10%. We can rearrange the equation for income elasticity of demand to use these values to calculate the percent change in demand. After plugging in the elasticity coefficient and the percent change in income, we find that if the income elasticity of demand is 0.3 and income increases 10%, then demand will increase 3%. Suppose that in Bolivia, the income elasticity of demand is equal to 1.2. What effect would a 10% increase in income have on the demand for beef? Plugging in these two values, we get a 10% increase in income would lead to a 12% increase in demand. This hypothetical value suggests that in Bolivia, beef is a luxury good because demand increases more than income. Similar to the case with price elasticity of demand, when it comes to income elasticity of demand for most goods, more time means larger elasticity. Suppose that your income drops sharply during a recession. In the short run, you may have to continue to buy as much gas as you did before your income decreased, because you still drive the same car, still work for the same company, and are still dating the same person. But if your income drops and stays down, you may start making some changes to avoid using as much gas. For example, you might start carpooling to work or replace your car with a bike. Many of the actions you may take to use less gas take time. So with more time, you have more options to avoid gas. So income elasticity increases with more time. Also similar to price elasticity of demand, when it comes to income elasticity of demand, the relationship between time and the size of the elasticity is flipped when it comes to durable goods. This is because the existing stock of durable goods is large compared to annual production. Suppose you are planning on buying a new refrigerator when a recession hits, causing a substantial decrease in your income. Since you already own a refrigerator, and there are a lot of used refrigerators available, you can avoid buying a new refrigerator in the short run. You can make use of the existing stock of refrigerators to avoid buying new. So in the short run, there was a sharp response to a change in income. You went from planning on buying a refrigerator next month to not buying one. However, with time, the existing stock of refrigerators continues to wear out. Even if the recession continues, so incomes continue to be low, with time, more and more people decide it doesn't make sense to continue to repair the old refrigerator, so they go shopping for a new refrigerator. Generally, in the long run, the income elasticity of demand is smaller than in the short run for durable goods. This is why demand for durable goods is so cyclical. When a recession hits, the spending on durable goods drops sharply in the short run. Income elasticity of demand can be used by a business to help assess how recession-proof their business is. If they produce an inferior good, a recession may actually be good for business. Imagine you're an executive for Coca-Cola and you're wondering what will be the effect of some recent price changes made by Pepsi on the demand for Coke. What you need to know is the cross-price elasticity of demand between Coke and Pepsi. Cross-price elasticity of demand is equal to the percent change in quantity demanded for one good, good X, over the percent change in the price of another good, good Y. For our example of Coke and Pepsi, good X would be Coke and good Y would be Pepsi. We are interested in how responsive are Coke consumers to a change in the price of Pepsi. If the price elasticity coefficient is positive, then there is a positive relationship between the price of good Y and the demand for good X. That is, when the price of Y goes up, then the demand for good X also increases. If the cross-price elasticity of demand coefficient is positive and the price of Y goes down, then the demand for X will also decrease. When the goods are complements, then the change in the price of good Y is inversely related to the change in the demand for good X. If the price of Y increases, the demand for X will decrease. Here are some real-world cross-price elasticity of demand coefficients between Coke and Pepsi. We can see that the cross-price elasticity of demand between Coke and Pepsi was 0.34 in 2005. The fact that this number is positive implies that they are substitutes. If we rearrange the equation for the cross-price elasticity of demand, we get that the percent change in the demand for X is equal to the coefficient times the percent change in the price of good Y. Recall that the price elasticity of demand between Coke and Pepsi is 0.34. What effect would a 5% increase in the price of Pepsi have on the demand for Coke? Please solve this problem. The cross-price elasticity coefficient predicts that the demand for Coke will increase by 1.7% following a 5% increase in the price of Pepsi. You can use the same equation to predict the effect of a change in the price of Diet Pepsi or a change in the price of Diet Coke. Please answer this question. What will have a bigger effect on Coke, a change in the price of Pepsi or a change in the price of Diet Pepsi? We can see that the coefficient for Diet Pepsi is larger than the coefficient for Pepsi. So Diet Pepsi is a better substitute for Coke than Pepsi. A 10% increase in the price of Diet Pepsi will lead to a 4.5% increase in the demand for Coke. You can see that the cross-price elasticity of demand enables analysts to forecast the effects of price changes on the demand for substitutes or complement products. The coconut oil demand function is given by this equation, where Qx is the quantity of coconut oil demanded in thousands of metric tons per year, Px is the price of coconut oil in cents per pound, Py is the price of palm oil in cents per pound, and I is the income of consumers. Assume that the price of coconut oil is 45 cents, the price of palm oil is 31 cents, and income is 1.5. What is the cross-price elasticity of demand between coconut and palm oil? Recall that the elasticity equation can be written in terms of the slope coefficient as follows. In this case, the slope coefficient on the price of palm oil is 16.2. This shows that every time the price of palm oil goes up by 1 cent, the demand for coconut oil increases by 16.2 metric tons. Plugging in the values for income and prices into the demand equation, we get a quantity of 1,275 metric tons of coconut oil. Now plugging all these values into the cross-price elasticity equation, we find a cross-price elasticity of 0.393. Please answer this question. Does this coefficient imply that coconut oil and palm oil are substitutes or complements? The positive coefficient implies that they are substitutes. We can follow a similar pattern to solve for the income elasticity of demand or the price elasticity of demand. Let's solve for the income elasticity of demand here. Recall that the income elasticity of demand equation is given by this. Here the slope coefficient on income is 0.2. Once again, plugging in the values for income and price into the demand equation, we get a quantity of 1,275 metric tons of coconut oil. Now, plugging all these values into the income elasticity equation, we find an income elasticity of demand of 0.00002. The positive coefficient implies that the coconut oil is a normal good, but the really small number suggests that a change in income really doesn't have much of an effect on coconut oil. You can now follow the same pattern to solve for the price elasticity of demand. Please go ahead and do that here. Recall that the price elasticity of demand equation is given by this. Please note that this coconut oil demand function was actually estimated from real-world data. You can see that the coefficient on price is negative 9.5. Now, plugging all these values into the price elasticity of demand equation, we find an elasticity of demand of negative 0.34. Okay, one more question. Does this coefficient imply that coconut oil is elastic or inelastic? We can see that it is inelastic because the coefficient is a fraction. It is greater than negative 1.